Today I will be presenting on data analysis. All right, data analysis is the process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information to suggest conclusions and support decision making. So this chart essentially defines the process. First, you start with reality, which is where we live in and the world around us, which then can be led into raw data collected, which is what we have inferred from reality. That moves on to the data being processed and just shifted into what we want to use and whatnot. And then into a clean database set, so cleaning up the errors and all that kind of stuff, which I will talk about later on in this presentation. And then the clean set can either go into exploratory data analysis, which I'll explain, or into models and algorithms that could be further sent to data production or communication to communicate the visual report. And lastly, to make the decision. From this web, you can kind of see that there's really no right answer. You can go a lot of different ways and maybe repeat steps and go back and stuff. But essentially, you really want to make a decision and collecting data. All right, so data collection is the act of consolidating necessary data to be then further processed. Different types of collecting data can be Excel charts, cameras, satellites, recording videos, and interviews. So as long as it's some type of mode of getting variables that you need, like age, income, favorite colors, anything you really want for your business, to whatever data variables you really want to essentially. Next is data processing. So once you get all your variables and how many people you have, or what age, or what income, or favorite colors, you organize your data in a format that is the easiest to read. So you can have a spreadsheet of age, how many people were from, or 20 or 21, 22, your income, how many people make below $20,000 a year, who makes $70,000 a year, or statistical software. So I will be talking about that later, but you just want to have it organized so that you can like see from the data you collected, seeing this visually. Next is data cleaning. So after you've collected and processed your data, there's the possibility that data might be incomplete or contain duplicates or errors. Cleaning the data will prevent and correct any mistakes. So some ways to clean up your data is record matching, deduplication, column segmentation. You just want to make sure that your age, income, and colors have it. Since I've been using that example, you want to make sure that is the best. It's cleaned up the way that you need it to be cleaned up to make sure you have no errors so that you can go into the next step. So exploratory data analysis, or EDA, is analyzing data sets to summarize the main characteristics with visual methods. It's intended for seeing what the data can tell us beyond a formal model or hypothesis testing task. Some EDAs are box plots, histograms, and scatter plots. So maybe you want to make a scatter plot of the income of the SLU teachers here at SLU. Like, you would want to point how many years they've been here and maybe how much they've made. So like to show yourself and others, like there's an increasing trend, like the longer you've worked here at SLU, the more you get paid. Maybe that's what you're trying to figure out. Or your histogram, you want to see how many people are 20 or 21, or et cetera, et cetera. Next, we have data visualization, which is creating a visual representation of the data. It helps users analyze and reason about the data and evidence. So the things I mentioned before, previous to this slide, could be visual representations. You have a pie graph, you have a histogram plot on a slide to show us how you would see data. People describe data visualization as art and science. You want to really communicate what you found, but make it artistic and have colors and make it pop and make sure people can really understand what you were trying to say or trying to show. So there are eight different ways to communicate data. The first is the time series, which is a single variable captured over a period of time. 2 we have is ranking from highest to lowest, whoever's the oldest or the youngest, if we're looking at age. Part to whole is comparing a ratio to the whole, so like a pie chart of seeing how many percentage of X is located to the bigger X. Deviation compares the variable against a reference. 5th, we have frequency distribution, which is the number of observations of variable in a given interval. Correlation is comparing two variables that you want to see if they do or do not have a relation. Like how I said earlier, does the number of years you worked here at SLU indicate a higher pay raise? 7th is nominal comparison, which is comparing categorical subdivisions in no particular order. And lastly, we have geographical, which is comparing variables across a map or layout. So some software, there's some software to help us out if we ever want to analyze some data. The first one I'd like to talk about is DevInfo, which is a database system developed by the United Nations that monitors human development. It was created in 2001. Countries can download the free software and customize it for their country. According to the internet, as of 2012, 120 countries have used DevInfo for as their national statistical database, which is pretty cool. So getting more and more data to see trends and all that stuff. Second is ELKI, which is a type of data mining that was just recently created in Germany. I think it's about 8 months old. Its purpose is to allow the development and evaluation of advancing data mining algorithms and their interaction with database index structures. ELK can be used on Microsoft Windows, Linux, and Mac operating systems, which we've already talked about in this class. Next, I'm going to talk about careers. So if people are interested in analyzing data, or I know SLU probably has some courses we could take if we are interested, but careers are in high demand because I think it is an ever-increasing industry and people really want to know all different business sectors, whether it be finance, accounting, marketing, and all that, want market research or research of the data of what they're doing. They can pay from $39,000 a year to $89,000 a year, which is a really big sustainable salary. If you have a degree in something else and you're not really focused on data analysis, you could always obtain a certification. There's a lot of online programs and probably schools that you could go to receive this. And lastly, I'd like to talk about the future of data analysis. I found 4 things that I think are really interesting, and I'd like to maybe further discuss them. So the first one is big data will face huge challenges around privacy. I know that a lot of stuff, like surveys, are one part of it. And I really hope that in the future that companies aren't taking information without a permission. I know not a lot of us read the fine print, but a lot of companies nowadays, I think, are. When you sign up for something, you essentially can be used in a survey or the data, or they can use your information and stuff like that. So hopefully there won't be too many debacles where it's without permission. Second is ways analyzing data will improve. I bet you in the next 5 years there'll be tons of more systems, programs, and whatnot that can further synthesize data faster, easier, and more reliable. Third is data volumes will grow. I think as many more people are born on this earth, a lot more data can be collected and consumed, and maybe even areas we haven't even thought of analyzing data. And fourth and foremost is the development of a chief data officer, which I think is actually really something that is the most interesting to me, because I could probably see that happening for a lot of the Fortune 500 companies and stuff like that. I really wonder if it's a thing now, or maybe I'm a little late to the game, but I feel like that could also be something that would be easily we see in the next 2 or 3 years. So in conclusion, I just want to say data analysis has a lot of different parts, as I've mentioned earlier, but in the end, you're supposed to the goal is to help you make a decision based on what's in front of you. So hopefully the data you receive is good enough to make a decision, and whatnot. So thank you so much for watching my presentation.